This lesson is about the atom. Take a look at the picture that you see on the right. Many students want to know, because of the atom and its small size, how is it that we know what we know about the atom? And to explain this, I've included this picture here. Consider the photographer. I was the photographer. What was I doing when I took the photo? You cannot see me, so how is it that you can predict what I was doing when I took the picture? Can you tell? You may have guessed that I was riding in a helicopter, and yet you cannot see the helicopter. You can see the helicopter's shadow. You can even see a portion of the helicopter's door, but without the context of even the shadow, you probably would have been hard to figure that one out. So you cannot see the helicopter, but yet you made a guess based on observations in the world around you that you know. This is what we call indirect evidence. Another example of indirect evidence is if you were to look at the flag on the flagpole and the flag was waving in one direction. You might infer about the direction of the wind, and even if the wind was moving gently or more quickly or briskly. And yet, you cannot see the wind. You can only see its effects. So you see indirect evidence of the wind. And it is this indirect evidence is how scientists have learned what they've learned about the atom. What is the atom anyway? The atom is defined as the smallest particle of a substance that can exist by itself, or it could be combined with other atoms to form a molecule. As we said, the atom is the smallest unit of matter that still retains the properties of the element. And we measure the mass of the atom using the atomic mass unit. The reason we do that is because the mass of the atom is so small that the prefix and the decimal point and the zeros that we would have to use to represent it if we were comparing it to grams, there would be so many zeros that it's just not a manageable number. And so we call it the atomic mass unit. The nucleus of the atom is in the center of the atom, and it has a positive charge. It holds the protons and the neutrons. Around the outside of the atom is the space called the electron cloud. The energy levels are here within the electron cloud, which is the most likely location of the electrons based on energy. Now, there are 3 subatomic particles that make up the atom that we are going to study. The protons, which are in the nucleus, they have a positive charge. Their mass is 1 AMU. Remember, that's atomic mass unit. So the proton's mass is 1 AMU. And the number of protons is going to be equal to the atomic number. Protons identify the element. So all atoms that have 1 proton are going to be atoms of hydrogen. All atoms that have 2 protons, or an atomic number of 2, will be atoms of helium. The number of protons identifies the element. Next, we have the neutron. The neutron is also found in the nucleus with the protons. Neutrons, if you look at their first 5 letters, N-E-U-T-R, those are the same first 5 letters for the word neutral, N-E-U-T-R, okay? So neutrons have a neutral charge, which can also be referred to as no charge. It's neither negative nor positive. It's neutral. Neutrons also have a mass of 1 AMU. And we determine the number of neutrons by taking the atomic mass, which is found on the periodic table, and subtracting the atomic number. Now, since the atomic number and the number of protons is the same, we can also rewrite that equation to be atomic mass minus the number of protons equals the numbers of neutrons. And the job or the role that the neutron has is it holds the nucleus together. Electrons have a negative charge. They are found out on the outside of the atom, or outside of the nucleus of the atom, in a space that's termed the electron cloud. In the drawing there, you will see rings. Now, we use those rings to be called as energy levels. When Niels Bohr first made a discovery and made a hypothesis or a claim that those rings were the path of the electrons like planets circle the sun, he was describing a definitive path. But what we know today is that electrons do not have a definitive path. They move in the form of a wave. And so their placement on these energy levels is merely based on their likely location due to energy. Sometimes they have more energy and are further away from the nucleus. Sometimes they are using less energy and are closer to the nucleus. The role of the electrons is to determine the reactivity of the element, how one atom reacts with or bonds with another atom.